Hello viewers, welcome back once again to my channel, Math Made Easy with PDY. Once again, it's just a great privilege coming your way with another lesson in mathematics. As you know, your support for the channel has been so awesome, and I'll be very glad for you to keep on supporting me by subscribing to my YouTube channel and then be sharing it with your friends. And then also, as you know, we have the Facebook channel as well. I want you to actually support the channel, and then that of the Telegram. So for the Telegram, it's still Math Made Easy with PDY. Kindly throw your weight behind the channel and then join the channel from Tuesday through to Friday for live mathematics lessons. Thank you so much, and then God richly bless you. Now, in today's lesson, we are actually going to look at rational functions. Everything that you need to know concerning rational functions, we are going to talk about it today. So, not to waste my time, what then is a rational function, or what are rational functions? Now, we can define rational function as any function written in the form of a fraction. Any function written in the form of a fraction. So a function f is rational if f of x is equal to g of x over h of x, where g of x and h of x are polynomial functions. In other words, a rational function is a ratio of two polynomial functions in which the denominator is not equal to 0. So from our expression here, then h of x must not be equal to 0. Why is it that it shouldn't be equal to 0? You know, mathematically, any number over 0 is undefined. So when the function h of x is assuming a value of 0, then the whole function does not exist. Hence, what are some of the examples of rational functions we can have? We can actually have f of x equal to 1 over x plus 2. It's a rational function. We can have g of x on its own also equal to square root of x plus 1 all over x squared minus 4. This is also a perfect rational function. So we have different kinds of rational functions, and in your own small way, you can generate your own rational function. You may also have k of x equal to x over x minus 6. It is also a perfect rational function. So what then can we also learn with respect to rational functions? We should be able to state the domain of a rational function. We should be able to state the domain. And interestingly, this topic is in both core and elective mathematics. But I'm starting with the core aspects, and then when we get further, we'll be dealing with the elective aspect. So in core math, they can ask you to state the domain of a rational functions. Likewise, in elective math, they can ask the same thing. So what then is the domain of a rational function? Now, the domain of a rational function consists of all real numbers except the zeros of the denominator of h of x. So the domain of a rational function of f of x consists of all real numbers except the zeros of the denominator. What it implies is that when you have any rational function to exist, the domain will be possible except when the whole expression for denominator is 0. So in other words, the domain is the set of all real numbers that can be used in place of the variable. Now, the steps you need to consider when we want to find the domain of a rational functions includes 1. First, equate the denominator. If it is h of x, equate it to 0, and then solve for the value of x. Now, when you solve for the value of x, then number 2, the value of x or involving any variable at all obtained is not part of the domain if it makes the denominator 0. So it means that whenever you are stating the domain, after solving for the value of x at the denominator, what it implies is that all values of x in the real number system will be part of the domain, except that value of x you obtained when you solved for the value of x at the denominator. So we'll be taking some examples on how to find the domain of a rational function. So some of the examples include: 1. Determine the domain of the following. If we should consider f of x equal to 4x plus 5, all divided by 3x minus 8, to determine the domain will be for all real numbers, or for all values of x part of the real number system, except a value which, when we substitute it into the value of x at the denominator, it will give us 0, and that will be the value that will make the whole expression undefined. So the first step is we select the denominator, which is 3x minus 8 equated to 0, and solve for x. That will be giving me 3x equal to 8. Because 0 plus 8, we have to transpose the negative 8 to give us positive 8. So x then becomes 8 on 3. So in this case, stating the domain of f of x, then you put it in curly brackets, x such that x is a member of R. X is a member of R, except x equal to 8 on 3. You can write it as this, or you can also state it as the domain of f of x is equal to x such that x is a member of R, which is the real number system, but x must not be equal to 8 on 3. So that is another way you could have stated the domain of the function. When you bring except, then it means you use x equal to 8 on 3. But when you don't bring except and you take it as but, x must not be equal to 8 on 3, still it makes the domain to be true. Okay, so we've been able to do this. Let us take the next example. So considering f of x equal to x plus 2 all over 2x plus 1, then we are going to have it as taking the denominator, which is 2x plus 1 equated to 0, then solving for x. 2x will be equal to negative 1. Hence, x will be equal to the value negative 1 on 2. So to state the domain will be of f of x will be in curly bracket x such that x is a member of R, except x equal to negative 1 on 2. Then you close the curly bracket, or you can say that x is such that x is a member of R, but x must not be equal to negative 1 on 2. Because when you substitute negative 1 on 2 into this function, the denominator will give us 0, and therefore it will make the function not to exist. Alright, moving on, the last example, when we pick the denominator, we have x squared minus 4, we equate it to 0. This is a quadratic equation. Hence, in solving it, we use factorization. So this is the idea of difference of two squares, and we are going to have it as x minus 2 multiplying x plus 2 all equal to 0. So when you solve for the value of x, you end up getting x equal to positive 2 or x equal to negative 2. So we have two sets of values which cannot be substituted into the function for it to make it undefined. Therefore, to state the domain, I'm just going to use only one method. The domain D will be equal to x such that x is a member of R, but x must not be equal to positive 2 or negative 2. Then you close the curly bracket. Remember, you can use except. When you use except, then you have to go for x equal to 2 or x equal to negative 2. I believe you've been able to understand how to state the domain of a rational function. Going further, then we have to look at the range of a rational function. In order to determine the range of a rational function, the range of a rational function is the same as the domain of the inverse function. The range of a rational function is the same as the domain of the inverse function. Now, ideally, when we talk about the range of a function, it is simply the functional values of y, or functional images in the y entries, which makes the statement true. So they have a good purpose performing with respect to the s component. So to state the range of a rational function, you simply need to find the inverse of that function. Then you state the range in terms of the y values. You state the range in terms of the y value. So first, you must find the inverse of the function. Then secondly, you find the domain of the inverse. And in stating the domain of the inverse, you state it in terms of y. You state it in terms of y. That's why we say that the range are the functional images in the y values. The functional images in the y value. So let's take an example to work on stating the range. So when we consider f of x equal to 4x plus 5 all over 3x minus 8, let f of x equal to y. So when f of x is equal to y, then it means we have it as y equal to 4x plus 5 all on 3x minus 8. In other words, we want to make x the subject from this statement here, and that will be given as y multiplying 3x minus 8 all equal to 4x plus 5. Now, we have to expand and simplify so that we group all the x's, and that will be given as 3xy minus 8y should be equal to 4x plus 5. We have some of the x values on the left hand side as well as some on the right hand side of the equal to sign. So grouping terms, we may have 3xy minus 4x equal to 5 plus 8y. Remember, we need to state the range in terms of the y value. So we have to make x the subject. So factorizing out to make x the subject, we have x out into bracket 3y minus 4 all equal to 5 plus 8y. So dividing both sides by 3y minus 4, then x will be equal to 5 plus 8y all divided by 3y minus 4. So we've been able to make x a subject. Then we can go ahead and then state the domain of this inverse. And in stating the domain, remember we have to consider the denominator. So picking 3y minus 4, equating it to 0, we'll end up getting y value as 3y equal to 4, and y will be equal to, dividing both sides by 3, we are going to end up getting 4 on 3. So in stating the range, you say that the range of f of x, then you introduce your curly bracket again. This time y is such that y is a member of the real number system, except y equal to 4 on 3. Or as I said early on, you can also say that y is such that y is a member of R, but y must not be equal to 4 on 3. Then you put it in curly brackets, and that gives you the range of the function f of x. The range of the function f of x. So let me use this small space over here to determine the range of the next example. To determine the range of the next example. So in our second example, we have f of x equal to x plus 2 all divided by s squared minus 4. In this scenario, we can still say that let f of x equal to y. So we have it as y equal to x plus 2 all divided by s squared minus 4. Now, if you look at it carefully, you realize that the numerator is a factor in the denominator. So we can simplify this whole expression before we go ahead and state the range of that function. So we are going to have it as y equal to x plus 2 all on x plus 2 multiplying x minus 2. So when you simplify, you end up getting y equal to 1 over x minus 2. Now that we've been able to simplify the function f of x, then we can go ahead and then make x a subject from the function. So in doing so, having y multiplying x minus 2 all must be equal to 1. Then we expand, we have xy minus 2y equal to 1. Making x a subject, we have to transpose the negative 2y. So we have xy equal to 1 plus 2y. Dividing through by y, we have x equal to 1 plus 2y all on y. So in this case, to state the range, as I said, the range is stated in terms of y. So the range is that it is y such that y is a member of R. And remember, we have only one expression at the denominator. So it means that where y is not equal to, let me write it down here. I need some small space. So let me just clean this and then write it well. So in stating the range will be y such that y is a member of R, but y must not be equal to 0, and that will be the range for question number 2, f of x equal to x plus 2 all over s squared minus 4, s squared minus 4. So I believe you need to practice as many work examples, but as I said, this video is all about everything that you need to know concerning rational functions. So we are taking them bits by bit. We have a lot of examples to work after the whole review of rational functions. So let's move forward. Moving forward, what we need to consider is evaluating rational functions when we are given the rational function and some values. So a rational function involving a variable has no value unless a value is assigned to the variable. Then once the variable is given a value, then the rational function can be evaluated. So we have one example here. It says that find the value of f of x, which is equal to 4x minus 1 all on x plus 2, for which x is equal to negative 3. So all that we know is that to find the value of f of x, wherever we see x in f of x, we substitute the value of negative 3 there. So 4x minus 1 all on x plus 2. So we are evaluating f of negative 3, and that will be giving us 4 times negative 3 minus 1 all on negative 3 plus 2. When you simplify the numerator, you are going to get negative 12 minus 1 all on negative 1. And the numerator will be giving us negative 13 all on negative 1. So the final answer becomes 13, because negative 1 can go into negative 13, positive 13 times. Therefore, when we evaluate the value of f of x when x is negative 3 for this rational function, the answer is 13. So that is one work example over there. We can also move on to the next aspect, which is reducing rational functions into the simplest form. Now, there are various steps to consider when reducing rational functions into simplest form. And the first step is that write the rational function for both the numerator and denominator in their factor form. Make it a point to write it in their factor form completely. And therefore, with the idea of division, you can do away with common factors for both numerator and denominator. Then you will end up reducing the rational function into its simplest form. So I have an example over here we need to consider. We have it as f of x equal to x squared minus 9 all on 6x plus 18. So if they say simplify, then it means that there's a way of reducing it automatically. So the numerator will definitely have a factor which is also in the denominator. So writing the numerator into a factor form, we are getting, when I look at it, it is actually difference of 2 squares. So in difference of 2 squares, we have it as x minus 3 and then x plus 3. When I expand this, I'll get the numerator, all divided by the common factor between 6 and 18 is actually 6. Then we have x plus 6 times 3 will give us 18. So the common factor is x plus 3 and x plus 3. So we can do away with that and it will be left with x minus 3 all on 6. So we've been able to simplify x squared minus 9 all divided by 6x plus 18 into a simplest form, into a simplified form. So that is how you could have worked on the work example 1. Then the next aspect is division of rational functions. Division of rational functions. So division of rational functions is similar to that of reducing a rational function into the simplest form. But in a situation whereby you have two rational functions dividing, then you have to think of changing the division sign into a multiplication sign so that you invert the other rational function. So division of rational function is similar to that of rational numbers. Therefore, invert the divisor and multiply, not forgetting that when it comes to multiplication, you must write the functions in their factor form and therefore you reduce them where possible. So division of rational functions is almost the same as reducing rational function to their simplest form. So we have one example here whereby there's a division between negative 3w minus 3w squared all over w squared minus 1. So in this case, negative 3w minus 3w squared all on w squared minus 1. As I said, write it in a factor form. And looking at it carefully, the common factor is actually negative 3w. Then we have 1, then plus w. When we multiply negative 3w plus 1 times 1, we'll end up getting negative 3w. Negative 3w multiplying w positive will give us negative 3w squared. Then the denominator, writing it in the factor form, will get difference of 2 squares. So we have into bracket w minus 1 and then w plus 1. Fortunately for us, 1 plus w is the same as w plus 1. So the common factors will be done away with, and then it will be left with negative 3w all over w minus 1. So there is no way we can do any other simplification here. Hence, our answer is left as negative 3w all over w minus 1. Since we have more to go, so let's move on straight. Multiplication of rational functions. So for rational functions, when you are multiplying them, you do it the same way as you multiply rational numbers. So rational expressions and rational expressions. So you just have to multiply the numerator separately and then the denominator separately. Where there is a need for you to factorize, please, you must do so that you reduce it into its simplest form before you finally multiply the remaining factors. So I have one example here if f of x is equal to x squared plus 7x plus 12 divided by 2x minus 6, and g of x is equal to x all divided by x squared minus 16. Find the product of, so we are finding f of x multiplying g of x. So this is going to give us x squared plus 7x plus 12, all divided by 2x plus 6, 2x plus 6. Then we have multiplying x on x squared minus 16. So we need to try and then write the numerator as a factor of two expressions, and then that of the denominator, when I look at it carefully, there is also a common factor between 2x and then positive 6. So in order to generate the factors for x squared plus 7x plus 12, now you can go back to my previous video concerning factorization, and then you get to know how I factorize quadratic trinomials very easily. So in doing that, now when I factorize x squared plus 7x plus 12, I'm going to get my values as x plus 3 and then x plus 4. So I have it as x squared plus 3x plus 4x plus 12 all on 2x plus 6. Actually, let me factorize it straight ahead so that I don't repeat myself. So that is going to be 2 out into bracket x plus 3, and I have times x all on x minus 4 multiplying x plus 4, because that is difference of two squares. Now when I factorize this quadratic polynomial now, so I can factorize first to, that is giving me x into bracket x plus 3, and the other will be plus 4 out into bracket x plus 3, all on 2 into bracket x plus 3, and times x all on x minus 4 multiplying x plus 4. So finally, my numerator, let me go up here to continue over here. So I'm doing it over here. I have my numerator as x plus 3 multiplying x plus 4, all on 2 into bracket x plus 3. And we have the other function as times x into bracket x plus 4 multiplying x minus 4. So you can see that x plus 4 is at the numerator here, so it can do away with x plus 4 at the denominator, because everything now is in the factor form. X plus 3 can also be done away with x plus 3 at the denominator here. So the numerator for f of x is left with 1. Multiplying x, it will give me x. All on the denominator here is left with 2. Multiplying one of the factors of the denominator here, so we have x minus 4. So finally, we can leave the answer as this, or we can write it as x all on 2x minus 8. And that is the answer to when you multiply f of x and g of x and you simplify it. This is the answer you will actually obtain. So moving on, we have a similar example. We are given f of xy equal to 2x minus 2y all on 4, and we have g of xy equal to 2x minus x squared minus y squared, and we have to multiply them. So finding f of xy times g of xy, and that is going to give us 2x minus 2y representing f of xy all over 4 equal to, multiplying So multiplying 2x all on x squared minus y squared. So going further, as I told you early on, it's best to write it in the factor form. So for the numerator, for f of xy, we have a common factor of 2 out into brackets x minus y. Then the denominator still have 4 multiplying 2x all on. Now, if you look at the denominator for g of xy, it is also difference of 2 squares. So we have x minus y and then x plus y. Now, doing away with common factors, 2 is a factor that can go into 4, and then 2 here can also go into 4. So this 2 times 2 will give us 4, and need to do away with the 4 at the denominator here. So we are left with x minus y. X minus y can also go into x minus y here. So at the end of the day, at the numerator, we have 1 and then times x. So we are left with x divided by, we have 1 at the denominator here. So we are going to end up getting x plus y times 1, which will give us x plus y. So finally, when we multiply f of xy by g of xy, we end up getting x all divided by x plus y. X plus y. So that is it. Moving on, we have another example here. This time around, they are dividing. Yeah, so since they are dividing, we have f of x dividing g of x. Remember, we can change the division sign to multiplication, and therefore we need to find the reciprocal of g of x. So going further, having f of x as 4 minus x squared all divided by x squared plus x, dividing g of x, which is x minus 2 all on x squared minus 1, maintaining f of x, but going ahead, we need to find the factors of it. So we have difference of 2 squares at the numerator again. So we have 2 minus x multiplying 2 plus x, all divided by the factor for x squared plus x is x out, x plus 1. Then we have multiplying, then we find the reciprocal of this, x minus 2 over x squared plus minus 1. So that will give us x squared minus 1 all over x minus 2. Hence, going further, we have 2 minus x all multiplying 2 plus x all over x times x plus 1. Then multiplying, the numerator can be written as x minus 1 and then x plus 1, because it's also difference of 2 squares. And the denominator will be x minus 2. So we can do away with common factors, which includes x plus 1 will go into x plus 1 here, and it will be left with x minus 1, and then we have x minus 2 here. Now, in doing so, let me work out this here on the side. We are left with 2 minus x all over x, then times x minus 1 all over x minus 2. Now, in order for us to be able to cancel out x minus 2 and 2 minus x, we need to do some simple operation here. So 2 minus x over x will multiply. Now we can factorize out negative 1. When we factorize out negative 1, we'll have x minus 1 at the numerator divided by negative 1 out into bracket x, because we want x to be a positive number, so it will rather be negative x. It will rather be negative x. So we factorize negative 1 out. We didn't want it to just look so different, so we factorize negative 1 out. So we'll be having negative x then plus 2. so that when negative 1 multiplies negative x, we get positive x, which is there. And when negative 1 multiplies positive 2, we get negative 2, so that it doesn't change the expression. So we'll have it as 2 minus x all over x times, now that negative 1 is out, the negative, even though it's affecting the denominator, it also affects the whole fraction altogether. So we are going to have it as negative x plus 1 all over 2 minus x. 2 minus x. Then now 2 minus x can be done away with 2 minus x here. So we are going to be left with 1 at the numerator and x at the denominator. So 1 multiplying the numerator, we end up getting negative x plus 1, and the denominator will just be x. So the answer for dividing f of x and g of x will be negative x plus 1 all on x. All on x. So moving forward, we are looking at addition and subtraction of rational functions. Now, we have different kinds or types. So taking them one after the other, we have type 1, when you have identical denominators. It's like adding and subtracting fractions, whereby they have common denominator. All that you need to consider is to select one of the denominators as your LCM, and then now you add or subtract the numerators. So the same idea comes to rational functions. So when you have identical denominators, add or subtract numerators whilst a common denominator is maintained. Then you simplify your answers where possible. You simplify your answers where possible. So let's take an example over there. Given that f of x is equal to 2x all over x plus 2 and g of x is equal to 4 over x plus 2, we should find f of x plus g of x. So it's simply going to be 2x all divided by x plus 2 plus 4 all on x plus 2. So we just find the LCM, and the LCM is x plus 2, because x plus 2 can go into itself 1. Therefore, we select just the x plus 2. Then we add the powers. So we add the numerator. So we have 2x plus 4. Now 2x plus 4, if you look at it carefully, you realize that x plus 2 can go into 2x plus 4. So let's factorize out and see what we obtain. We are going to get 2 out, x plus 2, all on x plus 2. So x plus 2 can go into itself 1, and it will be left with the answer as 2. So when we add 2x over x plus 2 and 4 over x plus 2, we end up getting the final answer as 2. Let's take another example over there. This time around, we have f of x as x squared plus 2x all over x minus 1 multiplying x plus 3 as a denominator. And we have a similar one, 2x plus 1 all on x minus 1 times x plus 3. This time we are subtracting. So having x squared plus 2x all on x minus 1 multiplying x plus 3, subtracting the next function, which is g of x, is 2x plus 1 all on x minus 1 multiplying x plus 3. In this case, they have a common LCM, so the LCM is x minus 1 multiplying x plus 3. That is what I can see as a common LCM. Now that goes into itself 1, so multiplying the numerator, we are left with x squared plus 2x. Then minus x minus 1 and then x plus 3 will go into itself 1, multiplying the numerator. Remember, this is a binomial, so it's supposed to be into bracket 2x plus 1. Then now we expand and simplify the numerator, and still our LCM will be maintained as x minus 1 multiplying x plus 3, and that will be giving us x squared plus 2x minus 2x. Then we have minus 1. So like terms here can be simplified, giving us 0. So we are left with, let me continue from the side here, we are left with x squared minus 1 at the numerator, all divided by x minus 1 multiplying x plus 3. As you know, to know whether we can go ahead and simplify, we have to write the numerator in a factor form so that we can look out for common factors to do away with. So x minus 1 multiplying x plus 1 will be the factor for the numerator because it's difference of two squares. Then we have x minus 1 multiplying another x plus 3 for the denominator. So we do away with the common factors, which is x minus 1 for both numerator and denominator, and we are going to be left with x plus 1 all on x plus 3. So that is how you add you subtract f of x and g of x, and you simplify it to obtain x plus 1 and then x plus 3. Moving forward, this time around we are taking an example whereby we have what we call different denominators. So the same way you look for least common multiple between the two factors, and then now you go ahead and solve it by adding or subtracting. But in all cases, you should see to it that you actually simplify your final answers. So one example is this. We have g of x plus f of x, which is 1 on x squared minus 9 plus g of x, which is 2 on x squared plus 3x. Now, there's a clue I want to give to you over here. Now, if you want to find the LCM between two rational functions, it is always advisable to write them in a factor form for the denominators so that you can easily select out the common factors and then the other uncommon factors. If you have some common factors, you select one of them, and then the uncommon factors, you just pick those which are uncommon and attach it to the common one you've already selected. So writing f of x in a factor form, it is x minus 3 and then x plus 3, because it is difference of two squares. That will give you the factors of that x squared minus 9 plus, then we have 2 divided by the common factor between x squared and plus 3x is x into bracket x plus 3. So now, finding the LCM, as I gave you the clue, look out for common factors. Common factors is actually x plus 3. So we've selected one of them. Then the other ones which are not common, you bring them on board. So that is, one is x minus 3, and the other variable is also x. So the LCM for x minus 3, x plus 3, and then x and x plus 3 is x into bracket x plus 3 multiplying x minus 3. And that is how you write it. So simple, very, very simple. So now, how many times can this factor or denominator here go into the LCM? It goes there, the factor which is not found in the denominator, and which is x. Then x multiplies the numerator 1, and it gives us x. Then we have plus. Now, x multiplying x plus 3 will go into the LCM here. How many times? It will go there, the factor which is not among x into bracket x plus 3, and that is x minus 3. And that will multiply the numerator, and that will give me 2 into bracket x minus 3. And that's a very simple way of doing things. So, going further, then we can expand and simplify the numerator. We get x plus 2x, then minus 6, all on x into bracket x plus 3 multiplying x minus 3. Now, simplifying the numerator, we'll end up getting 3x minus 6, all on x into bracket x plus 3 multiplying x minus 3. So, looking at it, the numerator can be written in the factor form, which is 3 out into bracket x minus 2. X minus 2. So, in other words, when we go further, x into bracket x plus 3 and then x minus 3. Let us look at it. Can we do away with any common factor? And the answer is perfectly no. There's no factor in the numerator that can do away with any of the factors at the denominator. So we can leave our answer as 3 into bracket x minus 2, all divided into by x into bracket x plus 3 times x minus 3. X minus 3. So that is how far we can come with adding f of x and g of x. Going further, we have this time around subtraction. Subtraction between two functions. Subtraction between two functions. So subtraction between two functions, we have f of x as 4 on x minus a, and then we have minus g of x, which is 2 divided by x minus 5. Now, since we don't have any common factor between x minus a and then x minus 5, then it means we just bring them together as x minus a or multiplying x minus 5. And therefore, x minus a will go into the LCM x minus 5 times. Multiplying the numerator, we have it as 4 into bracket x minus 5. Then minus x minus 5 will go into the LCM x minus a times. So it will be 2 multiplying x minus a. Then we simplify the numerator, expand and simplify. We have 4x minus 20 minus 2x, then plus 2a, all divided by x minus a multiplying x minus 5. Then the question is there a way of simplifying any of the numerators? And yes, it is. So simplifying the numerator, we have it as 4x minus 2x, giving us 2x, then minus 20, then plus 2a, all divided by x minus a multiplying x minus 5. Then the question is there a way of factorizing out? Is there a way of factorizing out? Yes, we can factorize out 2 for the numerator, but if we do so, it doesn't have any effect on that of the denominator. So we can't go any further than to leave the answer as 2x minus 20 plus 2a, all on x minus a multiplying x minus 5. So that is where we can leave the answer. So going further, now we've gotten to the aspect whereby it is purely for elective math students. Purely for elective math students. And that is partial fractions. Partial fractions. So the question now is, when we talk about partial fraction, what is it all about? It is simply expressing any rational function into separate, the addition of separate fractions. Expressing rational functions into the addition or subtraction of different fractions. So we can consider a particular rational function as 2 over x squared minus 1. When you split it into a partial fraction, it becomes 1 over x minus 1 plus negative 1 over x plus 1. Then the question is, how was this done? How was this done? That is what we'll be doing in some few minutes to come. So by adding the fractions 1 over x minus 1 and negative 1 over x plus 1, we obtain 2 over x squared minus 1. Therefore, we say that the expression on the right hand side of the equation is called the partial fraction decomposition of 2 over x squared minus 1. So that is a partial fraction decomposition of 2 over x squared minus 1. So for partial fraction decomposition of f of x over g of x to be found, it is essential that f of x have a lower degree than g of x. So what it implies is that always you should have the rational function as a proper rational function before you can go ahead and find the partial fraction decomposition. You must always see to it that the highest exponent of the variable at the numerator is always lesser than the highest exponent of the variable at the denominator before you go ahead and then find the partial fraction for that. So, for example, given that x cubed minus 6x squared plus 5x plus minus 3 all divided by x squared minus 1. Now we need to find the partial fraction for it, but because the numerator has a power which is higher than that of the denominator, we need to first use long division. And if you don't have any idea as to how to divide polynomial functions, then it means you can go back to my videos, and I've taught that one as well. You can get the procedure. You can get a procedure using the long division to reduce fractions into two forms. So it means the partial fraction for that, we first have to find how many times can x squared minus 1 will go into the numerator, and it goes there x minus 6 times, plus a remainder of 6x minus 9, and then divided by x squared minus 1. Therefore, when you are going to write a partial fraction, x minus 6 becomes part of the partial fraction, but we need to find the decomposition of this 6x minus 9 all over x squared minus 1. And therefore, we'll be doing similar examples later on in our discussion. So let us move on to conditions we need to have in mind when you are writing the partial fraction for any rational function. So we have different types we need to consider. So the first type is that a partial fraction decomposition in which each denominator is a linear function. It's a linear function. So a partial fraction or a rational expression with a linear denominator is decomposed on the right hand side as shown. So if you have a numerator with only x, remember we are talking of linear denominator. The linear denominator, what makes it a linear denominator? The highest exponent of the variable x should be to the power 1. So I have a linear denominator of x alone. Therefore, the partial fraction is a over x. If I have a linear denominator of two separate linear functions and they are different, it becomes, for the first linear factor, we have x over a over x, and the other, which is s plus e, should be b over x plus e. So it means you write a partial fraction for the first factor, which is linear, and then the second factor, which is also linear. But in all cases, because you don't know the numerator you are going to have, you represent it with variables capital A, capital B, and it goes on and on as the number of linear factors increases. As the linear factors increases. So if you have about 4 different linear factors, you are going to have 4 separate partial fractions for that. 4 separate partial fractions for that. So please take note, the first kind, when you have a denominator with a linear factor, you have to write a partial fraction for each of the linear factors. So let's take one example and see the way forward. So one example is that you should write the partial fraction for 8x minus 1 all divided by x minus 2 times x plus 3. So in this case, having 8x minus 1 divided by x minus 2 multiplying x plus 3, we say that you have to consider the denominator. But before you write the partial fraction for it, you must check whether the highest exponent for the numerator is lesser than the highest exponent for the denominator when expansion is made. If you look at it carefully, the highest exponent for the denominator is going to be x squared, but the numerator is x, so it means we can go ahead and write the partial fraction. So then, because it's type 1, why is it type 1? We have 2 separate linear factors. Then we write partial fraction for each of the linear factors. So that's going to give us, the first partial fraction will be having a variable a divided by x minus 2. Then plus, we write another partial fraction for the next, which is going to be b over x plus 3. So we are going to find ways and means to solve for the value of a and b, and we have different ways of doing it. You can either use the prediction approach to solve it, or you can use the expansion and simplification approach to get it done. So in this case, I'm going to use one method so that it will be easier for you to apply it in the other subsequent ones to come. So solving for a and b, we must get rid of the fractions. So we multiply through by the LCM, and the LCM for the whole function is s minus 2 times s plus 3. So that is going to be multiplying the left hand side by the LCM. We are going to be left with 8x minus 1, and that should be equal to, when you multiply the LCM by a over x minus 2, you end up getting a into brackets x plus 3, because the x minus 2 will cancel out the s minus 2, and it will be left with this. Then plus, when we multiply b over s plus 3 by the LCM, which is x minus 2 times s plus 3, we are going to be left with b into brackets x minus 2. Then at this moment, you can choose to use, as I said, the prediction method. Since if you want to solve for b, then you have to get rid of a. Or if you want to solve for a, then you must get rid of b. So you predict that, okay, what value of x must be substituted so that we get rid of a? Or what value of s must be substituted so that we get rid of b? So you can use that method to get the value of a and b simultaneously. Or you can expand and simplify and solve for a and b accordingly. So using the prediction approach, we are going to have, when x is equal to the number -3, because it's -3 when you substitute here, it will give you 0 in the bracket, and 0 multiplying a will end up giving a 0. So when x is equal to -3, we substitute it into the expression above. So we have 8 times -3 minus 1 equal to a into brackets -3 minus 3, plus 3, then plus b into brackets -3 minus 2. When we simplify, we end up getting -24 minus 1 equal to, the whole of this will be given as 0. So we are going to be left with -5b, -5b. Simplifying, this will give me -25 equal to -5b. Dividing through by -5, we'll end up getting b as the number 5. B as a number 5. Now, since that we have b, we can use the same method to find for a. So we can say that when x is equal to, what number do you think will be substituted so that it will give us a whole of b to be 0? So when x is 2, therefore we are going to have 8 times 2 minus 1 equal to a into bracket 2 plus 3, then plus b into bracket 2 minus 2. So in this case, b will be given as 0 here, and we will be doing away with b automatically. Then here will be 16 minus 1 equal to 5a. So we are left with 15 equal to 5a. And therefore, dividing through by 5, a will be equal to 3. So we've been able to get the values of a and b. Therefore, this implies that our function, which was 8x minus 1 divided by bracket s minus 2 and then x plus 3, the partial fraction is supposed to be 3 on x minus 2 plus 5 on x plus 3. So this is the partial fraction for 8x minus 1 all over x minus 2 times x plus 3. You can add 3 on that and 5 on that, and frankly speaking, you are going to get the same answer. So without wasting my time, let's go to the next example. We have more to cover. So let's go to the next example, which is 3x squared minus 16 all over x squared minus 4x. So with the second example, we are to write the partial fraction for this expression. So before we do so, we need to actually consider what type of denominator we are having. But before that, you should note that before you can write a partial fraction, the rational function must be in a proper rational function form. So in this case, since we have the highest exponent for the numerator as s squared and that of the denominator also as s squared, then it would be advisable to first separate and know the whole factor which is found in here, or how many times can s squared minus 4s go into the numerator. So we can use the long division method to first break the two functions. So we are going to have s squared minus 4x, and then we'll have our dividend as 3x squared minus 16. But to write it in the standard form for easy division, then we should have plus 0x plus 0x and then minus 16 minus 16. So how many times can s squared go into 3s squared? It will go in 3 times. So we have 3 here. 3 multiplying s squared will give us 3s squared. 3 multiplying negative 4x will give us actually minus 12x. Then now we subtract. When we subtract, 3s squared minus 3s squared will give us 0. And that will give us 12x minus 16. We push out the 16 here. So that is our remainder. Hence, we having 3s squared minus 16 all on s squared minus 4x. The first factor, the denominator actually went into 3s squared minus 16 3 times. Then plus the remainder was 12x minus 16 all on the divisor, which is s squared minus 4x. So one of the partial fractions for this rational function is 3. So the other, which is a proper rational function now, and it needs to be decomposed into 2 separate functions, we are going to consider that as 12x minus 16 all on. Then we write the s squared minus 4x as a factor of x out into bracket x minus 4. Looking at it carefully, then we can also think of having, you see, reducing the rational function here also into probably 4 out, or we can choose not to do that, but we can just go ahead and then, because I was thinking there was another factor for the numerator, but it can't be. So we just have to write the partial fraction for x, which will give me a on x, plus the other factor as b on x minus 4. So we multiply through by the LCM, and it will be left with 12x minus 16 equal to a into bracket x minus 4 plus b into bracket x. Hence, you can go ahead and use the try and error method to get rid of a and solve for b, or get rid of b and solve for a. So using that method, when x is equal to 4, it means I'll be getting rid of a, and then I'll be finding b. I'll be having 12 times 4 minus 16 equal to a into bracket 4 minus 4, giving us 0. plus b into bracket 4. So we are left with 12 times 4. That gives us an answer of 48. So we have 48 minus 16 equal to 0 plus 4b. So 48 minus 16 leaves an answer of 32. So we have 32 equal to 4b. So dividing through by 4, b will be equal to. So divided by 4, we have b as 8. B is 8. Now, with the same try and error method, we can say that when x is equal to 0, we are going to end up getting 12 times 0 minus 16 equal to a into bracket 0 minus 4 plus b times 0. So we are left with negative 4a equal to negative 16, and obviously then a value dividing through by negative 4 will end up giving us a as 4. So ideally we've seen that our a value is 4, our b value is 8. So in other words, what it implies is that, let me use a different color let me use the yellow color. The partial fraction for 3x squared minus 16 all on x squared minus 4x will be equal to 3 plus, remember we wrote the partial fraction as a over x, so a value is actually 4 over x. Then the b value is also 8, so 8 over x minus 4, and hence that's the decomposition of 3x squared minus 16 all over x squared minus 4, and that's the partial fraction decomposition of that. You can go ahead and then add up 3 plus 4 over x plus 8 over x minus 4, and frankly speaking, you are going to get the answer on the left hand side of the equal to sign. Good. So we have more to go. Then we move on to type 2. The type 2. For type 2, it is a type of partial fraction decomposition whereby it contains a repeated linear factor. It contains a repeated linear factor. So a rational expression whose denominator contains a repeated linear factor is decomposed on the right hand side as shown below. So when you have a repeated linear factor, then you have to write the partial fraction for the factor, the linear factor itself, which has not repeated itself. Then you write it for the repeated factor as well. So for instance, over here it means I have 3 different factors here. I have x, so I'll write the partial fraction for x, which is linear, so it's supposed to be using one variable for the numerator. Then x plus e, you write the partial fraction for that. Then you write the partial fraction for x plus e all squared. So it means you are going to have 3 separate partial fractions for such a rational function. In the same way, over here, it means I have 4 different factors. And the 4 different factors, the first factor is x. Then I write it for x plus e, which is not repeating. Then x plus e repeating itself twice, and then x plus e repeating itself the 3rd time. So you have 4 different factors, partial fraction for this rational function. So the whole concept here is that when you have a rational function which has a repeated factor, first write a partial fraction for the factor not repeating itself, then write a partial fraction for the factor repeating itself once, then factor of the rational function repeating itself the next or the highest, and therefore this is what we have. So we are going to take an example so you understand it perfectly how this idea works. And therefore, first example we have is this. find the partial fraction decomposition of the following. So we have 2x plus 3 all on x minus 1 all to the power 2. Remember, before you write a partial fraction for it, you must analyze or test whether the highest exponent for the numerator is lesser than that of the denominator. And frankly speaking, yes, the highest exponent for the numerator is way lesser. The power of the numerator, the variable s, is 1, but that of the denominator, when we expand, we get 2. So then we now consider, is it repeating factor and is it linear? Yes. So we have to write a partial fraction for the linear factor itself, which is not repeating itself. So we are going to have a on x minus 1 plus, then this time around, the linear factor repeating itself, that will be b on x minus 1 all squared. Then we are going to solve for the variables a and b we have actually introduced. And in doing so, the same way, get rid of fractions, and we are going to multiply through by the LCM, which is x minus 1 all squared. So left hand side by x minus 1 all squared will give us 2x plus 3 left equal to, over here we'll have a into bracket x minus 1 all squared, because when you multiply x minus 1, it will be left with just x minus 1. Good. It's 11. Because when you multiply x minus 1 all squared by a over s minus 1, it will cancel out one of that s minus 1, so it will be left with just s minus 1. Then plus multiplying through b over s minus 1 all squared by s minus 1 squared, we are going to end up leaving b left. So at this moment, solving for a and b, as I said, you can choose to use the try and error method. And in this case, if you want to get rid of a, then you must substitute a value of x, which will make it possible for a to be done away. So what will be your guess? The value of x that can be substituted to get rid of a so that you can find b is the number 1. So when x is equal to 1, then we have 2 times 1 plus 3 equal to a into bracket 1 minus 1 plus b. 1 minus 1, 0 times a is 0. So we are left with b equal to 2 times 1, 2 plus 3, 5. So b is 5 straight ahead. But now it's left for us to find the value of actually a. We can use the try and error method again. So that brings on board the other idea of expansion and simplification and comparing. So we have left hand side as 2x plus 3 equal to right hand side ax minus a then plus b. So in this case, you compare the coefficients. So coefficient of x on the right hand side is a. When you compare it to the coefficient of x on the left hand side is the number 2. So automatically we've seen what the value of a is. In the same way, you could have gone ahead to compare the true constant with the true constant on the right hand side, the ones without the variable x. So that is going to give me 3 on the left hand side equal to negative a plus b. Obviously, we found b already, but to confirm that the answer for b is actually 5. Now, since we know a value as 2, you can substitute a into the expression. So that's equation 1 and that's equation 2. You can substitute the value of 2 in place of equation 2 and you have 3 equal to minus 2 plus b. And therefore, transposing negative b to join the 3, you have 3 plus 2 equal to b. And then b is equal to actually 5. And it's the same thing here. So you can merge the two methods to get your answer and you are cool to go. You are cool to go. So in this case, the partial fraction for, let me use the yellow marker to finalize it, 2x plus 3 all on x minus 1 all squared. When we write the partial fraction decomposition, it will give us a value was A value was 2, all on x minus 1, plus b value, which was 5, all on x minus 1, all squared. So that's the partial fraction decomposition for that question. So moving further, going to example number 2. Example number 2, we have it as x squared plus 10x minus 36, all on that. Now, if you look at it carefully, you realize that we have one linear factor and then a repeated linear factor. So, and we have to check. The highest exponent of the variable x for the numerator is 2. That of the denominator will be 3. So, we are going to write 3 separate partial fractions for this. And that will be given as x squared plus 10x minus 36, all on x into bracket x minus 3, all squared. So we write a partial fraction for the first linear factor, which is x. So we have a on x plus the next is the linear factor, which is not repeating itself, so it will be b on x minus 3. Then finally c on the linear factor repeating itself, so x minus 3, all squared. Then going further, as you know, we must get rid of the fraction. So we multiply through by the LCM, and the LCM is x into bracket x minus 3, all squared. So when we multiply the left hand side by that expression, we are left with x squared plus 10x minus 36. And this should be equal to, when you multiply x squared, x into bracket x minus 3, all squared, by a on x, it will be left with a into bracket x minus 3, all squared. That's what will be left. Then plus, when you multiply the same LCM by b over x minus 3, we are going to be left with b into bracket x multiplying x minus 3. So this is what we have. This is what we have. Then finally, this will give me cx. Cx. That's going to give us cx. Now, to make it easier for us to solve it, I'll be very glad that we use the expansion simplification and then comparison approach to generate equations that can help us find the values of a, b, and c. We can't use the prediction method further because some of the factors are repeating themselves, and it will get rid of some and then leave others. So let's use the comparison approach to get the other factors done. So the left hand side still has x squared plus 10x minus 36, and this must be equivalent to a into bracket. When we expand x minus 3x, x minus 3 all squared, we end up getting x minus 6x plus 9. Then we have over here plus b into bracket x squared minus 3x. Then we have plus cx. Expanding and simplifying, we still have x squared minus 10x minus 36, x squared plus 10x minus 36 equal to this ax squared. So ax squared minus 6ax plus 9a, then plus bx squared minus 3, let me write it well, pardon me for that. So we have minus 3bx minus 3bx and then plus cx. When we rearrange so that it follows in order of powers of x descending, x squared plus 10x minus 36 should be equal to ax squared plus bx squared. We have the x squareds, 2 of them. Then let's come to the x's. We have minus 6ax and then minus 3bx and then plus cx. that is for the x's. And then the true constant, I believe we have only plus 9a left, plus 9a left. So comparing, one equation we can generate is that the s squared, coefficient of s squared can be compared with the coefficient of s squared on the left hand side. So on the left hand side we have coefficient of s squared as 1, and on the right hand side the coefficient of s squared is a plus b, so we can label it as equation 1. Then coefficient of x on the left hand side is 10, equal to coefficient of s on the right hand side is negative 6a minus 3b plus c, that is equation 2. Then the third equation is the true constant. So the true constant on the left hand side is negative 36, and that of the right hand side is 9a. So that is equation 3. Now looking at it carefully, you realize that we can actually simplify equation 3 to help us solve for the value of a. Then we can substitute it into equation 1 and get b, and substitute equation 1b and then that of equation 3 into equation 2, then we get c. And it's so simple. So in other words, from equation 3, 9a is equal to negative 36. So a will be equal to negative 36 on 9, giving us a value as negative 4. We've seen a value of negative 4. So substitute a into equation 1. So that will be giving us 1 is equal to negative 4 plus b. So b then will be equal to 1 plus 4, and b will be equal to 5. We've gotten b. Then we substitute a and b into equation 3. So in doing so, we have 10 equal to negative 6 times a value, which we know a value is the number negative 4. Then minus 3 times b value is 5, then plus c. So simplifying, we have 10 equal to positive 24, then minus 15 plus c. So when we have 24 minus 15, it leaves an answer of 9. So we have 10 equal to 9 plus c. So c is equal to actually 10 minus 9, which is 1. So we've gotten our values for a, b, and c. Hence, our partial fraction decomposition of that will be equal to, because I don't have enough space, I'm just going to write the partial fraction decomposition. A value was actually the number negative 4, so negative 4 over x. Then b value 2 was a negative number. Sorry, b value was positive number, which is 5. So we have plus 5 on x minus 3. Then the c value is also a positive number, so plus 1 on x minus 3 all squared. So this is the partial fraction decomposition for x squared plus 10x minus 36 all on x into brackets x minus 3 all squared. I believe you've understood this also perfectly well. I'm so grateful coming your way with this presentation. Everything that you need to know under under rational function, which includes partial fraction. So going further, we go to the third type whereby you have a partial fraction decomposition containing an irreducible quadratic factor. An irreducible quadratic factor, meaning having a quadratic factor that you cannot reduce it into two linear factors. Having a quadratic factor which you cannot reduce it into two linear factors. In such a scenario, then if a rational expression whose denominator contains an irreducible quadratic factor is decomposed on the right hand side, it will be shown as this. If you have an irreducible quadratic factor, the partial fraction will be bx plus c all over x squared plus a, because you can't write the denominator as a reduced factor. Therefore, you just attach bx plus c to get your expression done. So in this scenario, because we had one factor as linear and the other as x squared plus a, which is an irreducible quadratic factor, we first had to write the partial fraction for the linear factor, which is a over x, and then also the partial fraction for the linear factor, which is a over x, and then the partial fraction for the quadratic factor, which is irreducible. So that was bx plus c all over x squared plus a. Because we've used a already, we can't use a again in the next partial fraction. So that's why we continue with the letter as bx plus c. In the same way, if you had it in the other way around, meaning the quadratic factor, which is irreducible, coming first before a linear factor, then it means you are going to have the partial fraction for that as ax plus b all over x squared plus a, which is the quadratic factor for the denominator, then plus c over x plus a, which is the linear factor which follows up. So that is one systematic presentation you should be able to take note of, so that you know how to go about issues when you meet similar examples. So we are going to take first example to work things out. So the question now is, if I have to find the partial fraction for the decomposition of 9x squared minus 3x plus 8 divided by x cubed plus 2x, now what can I actually do? Can I write the denominator as separate linear factors or not? Now, if you look at it carefully, having my 9x squared minus 3x plus 8 all divided by x cubed plus 2x, you realize that I can write one factor as 9x squared minus 3x plus 8 all on x out into brackets x squared plus 2. And this is the only factor I can actually generate. I cannot split x squared plus 2 into any further linear factors. So in this case, before I go further, I needed to check whether the highest exponent of the variable x was lesser than that of the denominator, and truly it's lesser, so I can go further to write a partial fraction for it. So having 9x squared minus 3x plus 8 all on x into brackets x squared plus 2, per the arrangement I have here, then it means my first factor is a linear factor. So I write a partial fraction for it, which is going to be a on x. I use a variable to represent that factor. Then plus having a quadratic factor which is irreducible, then writing the partial fraction for it, it becomes bx plus c all on x squared plus 2. So this is the limit I can go, and now I have to solve for the values of a, b, and c. So in doing so, I must get rid of the LCM or the fractions by multiplying through by the LCM. So multiplying through by the LCM, which is x into bracket x squared plus 2, I'll be left with 9x squared minus 3x plus 8 equal to multiplying the same LCM by a over x. I'll be left with a into brackets x squared plus 2, then plus now bx plus c all on x squared plus 2 being multiplied by the LCM, which is s into bracket s squared plus 2, we are going to be left with bx plus c multiplying the variable x. So this is what we have so far. So again, in order to solve for the value of a, b, and c in our equation, I'm still going to use the expansion, multiplication, and comparison approach. So we have 9x squared minus 3x plus 8 equal to ax squared plus 2a, and then plus bx squared plus cx. This is what I have. So rearranging in order of magnitude, 9x squared in terms of descending powers of x minus 3x plus 8, I'll be having ax squared, then we have plus bx squared, then plus cx, and then plus 2a, plus 2a, plus 2a. So comparing and simplification continues from here. Comparing the coefficient of s squared, I have 9 on the left hand side, and that gives me a plus b on the right hand side. That is equation 1. Comparing the x's, I have negative 3. Coefficient of x gives me negative 3 on the left hand side. On the right hand side to give me c. That's equation 2. And then considering the true constant, 8 on the left hand side will be equivalent to 2a on the right hand side. That's equation 3. So from equation 3, From equation 3, solving for a to be 2a equal to 8, and therefore a will be equal to the value 4. A will be equal to the value 4. Now, finding b, substitute a into equation 1. Substitute a into equation 1. And that will be giving me 9 is equal to 4 plus b. Therefore, b is equal to 9 minus 4. And that will give us an answer of 5. So I've gotten all the values of a, b, and c. And hence, let me use a yellow color to write my decomposition. And hence, my 9x squared minus 3x plus 8 all on x cubed plus 2x. The decomposition was supposed to be a value, which is 4, on x plus bx. B value, we found the b value to be 5. So we have 5x and then plus c, and the c value was the number negative 3. So instead of writing plus negative 3, I'll write it as minus 3 directly. So minus 3, all divided by, we have x squared plus 2. So this is the partial fraction for this function altogether. That's the partial fraction for the function altogether. So let's take the last one, which is type 4. This time around, it's a repeated quadratic factor. So for repeated quadratic factor, it follows the same as the repeated linear factor. So you write a partial fraction for the quadratic factor, which cannot be factorized into two linear factors. Then you repeat it. You just simply have to repeat it. So for such a question, you have it at as plus b all over s squared plus 2a plus cs plus d all over s squared plus a all squared. So it's similar to that of the linear factor. So with that same idea, you can use it to solve other questions. So in this case, we have a simple example here which we can consider. So we have it as 5x cubed minus 3x squared plus 7x minus 3 all on s squared plus 1 all squared. Remember, s squared plus 1 is irreducible quadratic factor into linear factor. So we have to straight ahead write the partial fraction for that, which will give us ax plus b all over that factor, which is s squared plus 1. Then plus writing the repeated factor for that, that will give me cx plus d all on s squared plus 1 all squared. So this is what we have. Then now you must get rid of fractions so that you can solve for a, b, and c as well as d. So multiplying through by the LCM, which is s squared plus 1 all squared, we'll be left with 5s cubed minus 3s squared plus 7x minus 3. And that will be given as, how many times can the LCM do away with some factors here? It will be left with 1 of the s squared plus 1. So we are going to have ax plus b all multiplying s squared plus 1. And then plus cx plus d, because the same factor will cancel out itself, and that's what will be left. Then now again, expansion and simplification. By going back to explain something, you realize that I went ahead to write it because I knew that when I expand the denominator, the highest power of x at the denominator is always going to be higher than that of the numerator. That's why I went ahead to do that. But before you write a partial fraction, please, you must make it a point to check whether the numerator, the highest power of the variable under discussion, is always lesser than that of the denominator. If not, use long division to break them up. Okay, so going further, we have our 5s cubed minus 3s squared plus 7x minus 3 all equal to, expanding, we are going to have it as ax cubed plus ax, because as multiplying s squared will give me as cubed, as multiplying 1 will give me as, plus bx squared plus b, then plus cx plus d. So again, arranging it in order of magnitude so that I can easily compare 5s cubed minus 3s squared maintain plus 7x also maintain minus 3. Arranging in descending powers of s, we have ax cubed, then plus bx squared plus ax plus cx, then plus b, and then plus d. So that is the arrangement made. Now comparing the coefficient of s cubed here, a is equal to 3. A is equal to 3. And then the s squareds, I have only 1 here and only 1 there. So b is equal to negative 3. Sorry, a is actually equal to 5. Sorry. A is actually equal to 5. A is 5. A, that's the coefficient of, so a is 5. And then b is negative 3. Now coming to the coefficient of x, I have it as coefficient of x here is, on the right hand side is a plus c, and that is equal to coefficient of x here is 7. And then the true constant, which is having no variable, I have b plus d. B plus d is equal to negative 3. So that is equation 1 here, equation 2 there, equation 3 there, equation 4 there. So it's all about substituting a into equation 3 to get c, and substituting b into equation 4 to get d. So in doing so, we are going to have a value is 5 plus c equal to 7. So c will be equal to 7 minus 5, and c will be equal to 2. And again, b value is negative 3 plus d equal to negative 3. So you have d equal to negative 3 plus 3, and d is equal to 0. So our d value is actually 0. Hence, let us write the decomposition for the rational function over there, and that is going to be 5x cubed minus 3x squared plus 7x minus 3 all on x squared plus 1 all squared will be giving us a value. We saw a value as 5, so it was supposed to be 5x plus b. B value is negative 3, so it will be minus 3 all on x squared plus 1. Then c value was also 2, so plus 2x plus d. D is 0, so all divided by x squared plus 1 all squared. So this is the partial fraction decomposition of the function, rational function 5x cubed minus 3x squared plus 7x minus 3 all on x squared plus 1 all squared. Now, we've been able to go through this long journey. Let us look at some of the WASI questions given, both in section A and in section B. Okay, so looking at the first work example that we have here, WASI 2018, it was an object question. It says, given that P on 2x plus 1 plus Q on x minus 3 is equivalent to x minus 10 all on 2x squared minus 5x minus 3. Remember, this rational function has been decomposed to give you the partial fraction here. So straight ahead, finding for the values of P and Q, you just have to multiply through by the LCM, and the LCM is just a combination of 2x plus 1 and then x minus 3. That gives you 2x squared minus 5x minus 3 over there. So in other words, on the left hand side, we are going to have it as P into bracket x minus 3, then plus Q into bracket 2x plus 1, and that should be equal to x minus 10, because when you expand the 2x plus 1 and x minus 3, you are going to get 2x squared minus 5x minus 3, and when it multiplies x minus 10, it will be left with x minus 10. So expanding and simplifying, you can choose to use the, as I said, the prediction method, whereby you get rid of one function, the variable p, and then solve for q, or the other way around. So expanding, I have px minus 3p, ps minus 3p minus 3p plus 2qx plus q equal to x minus 10. Then grouping in terms of descending powers of x, I will have px plus 2qx minus 3p and then plus q equal to x minus 10. So comparing the left hand side and the right hand side, the coefficient of x is going to be actually p plus 2q on the left hand side, and on the right hand side we are going to have it as 1. That is equation 1. And then the true constant is negative 3p plus q equal to negative 10. That's equation 2. So you solve the two equations simultaneously. And remember, because this is section A, I wouldn't like to waste my time in doing that, so I can go for my calculator to help me do that. If you don't have any idea about how to solve simultaneous equation with the calculator, please look at the link up there, and then you get procedure in using the calculator to determine that. So in this case, when I use the calculator to solve for the values of P and Q, then what am I going to have? I'm going to have, press the mode button, select mode 5 and select 1. So you are going to have 1, enter 2, enter 1. Then you have the second equation to input its value. So you have -3, enter 1, enter -10. And that will be equal to, so my P value, using the calculator to solve it, my P value is equal to 3, and then my Q value is equal to -1. So when we look through, P being 3 and Q being -1, the answer is possible answer C. Possible answer C. All right. So moving on to question number 20. Question number 20, that is just May, June 2019. It is similar to what we just did. It is similar, but not the same. So in solving for P plus Q, because that's what the question was demanding, it's not finding P separately and finding Q separately, but this time it says find P plus Q. So in finding P plus Q, following the same procedure, we must get rid of the fractions. So we multiply through by the LCM, and it will be left with 1 is equal to P into bracket x minus 2, and then plus Q into bracket x plus 2. Then with this one, I would like to use the elimination method, whereby I'm going to, when x is equal to +2, then it means I'm going to get rid of P. So it gives me 1 is equal to P into bracket 2 minus 2, then plus Q into bracket 2 plus 2. And therefore that's giving me 0. So I have 1 equal to 4Q. And then Q will be equal to 1 on 4. I've gotten my Q value as 1 on 4. Then when x is equal to actually -2, it means it will be eliminating the value of Q from the equation. So that would be 1 equal to P into brackets -2 minus 2, and then plus Q into brackets -2 plus 2. Remember, I'll be getting 1 equal to -4P and -4P, and I'll be having 0 at Q. So in other words, I'm going to get, let me draw a line here to continue. I'll be having P value as -1 on 4, -1 on 4. But remember, the question says find P plus Q. So P value is -1 on 4, Q value is 1 on 4. So in other words, we are having 0. So the possible answer is B. The possible answer is B. Going further, we should resolve 3x minus 1 all on x minus 2 all squared. Remember, then the idea of repeated linear factor comes into being. Therefore, having 3x minus 1 all divided by x minus 2 all squared. For repeated linear factor, we said you write a partial fraction for the linear factor, which is not repeating. So it is a on x minus 2, then plus a linear factor again, a partial fraction for the linear factor repeating this time around. So you have b on x minus 2 all squared. Then we have to get rid of fractions so that we can solve for a and b. And in doing so, multiplying through by the LCM, which is x minus 2 all squared, we are going to get 3x minus 1 left on the left hand side equal to a into brackets x minus 2. One of the factors will be left, and then plus b. So expanding and simplifying, we'll have 3x minus 1 equal to ax minus 2a, then plus b. So comparing, a value will be equal to 3, which is the coefficient of x, and then comparing the true constant, -1 will be equal to -2a plus b. So if this is equation 1 and that is equation 2, we can substitute a into equation 2, and that will be left with -1 is equal to -2 times a value, which is 3, then plus b. Simplifying, we have -6 plus b equal to -1. Grouping terms, b will be equal to -1 plus 6. So b is equal to 5. B is equal to 5. So in other words, the partial fraction, let me use the green marker to write the partial fraction. The partial fraction, a value we've seen is 3 on x minus 2. Then the b value is plus 5 on x minus 2 or squared. So let's go through and check which of the possible answers has this as solution. We have 3 over x minus 2 all squared, and then 5 over that, and that is not it. So you should actually be very careful when you are selecting. Per the arrangement we made, it's supposed to be 3 over x minus 2 plus 5 over x minus 2 all squared. So you should be very careful as to how you arrange and select. So the answer is possible answer C and not D. So going forward, we have another question we should resolve into partial fraction. So having 2x plus 1 all on 4 minus x squared. Remember, first check if the highest exponent of the variable for the numerator is lesser than that of the denominator. And truly we've checked and everything is in place. So in other words, resolving it, we have to also check, can the denominator be written as 2 linear factors? And yes, it is. So in other words, we are going to have it as 2x plus 1 all on 2 minus x and then 2 plus x. Then now we can resolve that. So 2x plus 1 all on 2 minus x times 2 plus x, writing the partial fraction to be a on 2 minus x and then plus b on 2 plus x. That's what we have. So getting rid of the fraction so that you can solve for a and b, we have 2x plus 1 equal to a into brackets 2 plus x plus b into brackets 2 minus x. I believe you understand how I had it. I had to multiply the LCM through by that, a over that, and then it will be getting rid of the s minus 2 minus x, and it will leave with 2 plus x. That's why I wrote the 2 plus x. And then when I multiply the LCM by that, it will be getting rid of the 2 plus x, and it will leave with 2 minus x. That's why I have it as that. So again, I can use the elimination by substitution method here. So I can have it as when x is equal to positive 2, it will get rid of the b. So I'll have it as 2 times 2 plus 1 equal to a into brackets 2 plus 2 plus b into bracket 2 minus 2. 2 minus 2 will be giving me 0. 0 times b is 0. So we are left with 5 here equal to 4a. And therefore dividing through by 4, we have a equal to 5 on 4. 5 on 4. Then again, solving for b, then we can say that when x is equal to negative 2, so we have 2 times negative 2 plus 1, then that is equal to a into brackets 2 minus 2, then plus b into brackets 2 minus 2. This will be giving me 0. A times 0 is 0. So we are left with, let me continue from here. We are going to be left with, I'm continuing from up here. I've made some space a little. So let me make room for that. So I have 2 times negative 2 will give me negative 4. Negative 4 plus 1 will give me negative 3. And that is equal to 4b. So dividing through by 4, b will be equal to actually negative 3 on 4. So A is 5 on 4, and then B is negative 3 on 4. So let's substitute it into decomposition, and that is going to give me A value is actually 5 on 4, all divided by 2 minus x. That's what I have. Then plus B value is actually negative 3 on 4, all on 2 plus x. The expression as we see here can also be written as 5 on 4 into brackets 2 minus x, then plus, minus 3 all on 4 into brackets 2 plus x. So let's go to the possible answers and look out for which one satisfy our solution. So we have 5 coming first. So 5 and then 2 minus x minus 3 for 2. Okay, so the possible answer is actually B. B satisfies it. Okay, so we are almost through. Let's finish hard. Finishing hard, we have this. Given that 6s plus m all over that, it's equivalent to this. So find the value of m. Frankly speaking, the best way to solve this, for me, I would have advised that just simplify your 4 on x plus 5 minus 2 on 2x minus 3, and that will give you the m value because you just have to compare. So the LCM is x plus 5 multiplying 2x minus 3, and then you have it as x plus 5 goes into LCM, 2x minus 3, so you have 4 into bracket 2x minus 3, then minus 2 into bracket x plus 5. Expanding and simplifying the numerator, we are going to get 8x minus 12 minus 2x, then we have minus 10, all on x plus 5, all multiplying 2x minus 3. Remember, we can simplify the numerator. 8x minus 2x will give us 6x, and then negative 12 minus negative 10 will give us negative 22, all on x plus 5 multiplying 2x minus 3. So ideally, comparing it to 6x plus m all on 2x squared plus 7x minus 15, then it tells us that the value of m must be negative 22. The value of m must be negative 22, which is possible answer D. Possible answer D. So that's the best way I would have advised you to use it in getting the answer for the value of m. Yeah. Going to the question number 15. It is similar to what we just did here. So it's all about expansion, simplifying, and comparing. So when we expand x minus a all squared plus b, which is equivalent to x squared minus 10x plus 29, then we are going to get it as x squared minus 2ax then plus a squared. Remember, we've done expansion of factors. Then we have plus b, and this must be equivalent to x squared minus 10x plus 29. In this case, we compare the coefficient of x's because we are asked to find a and b. So we don't need a coefficient of s squared because they are the same. So coefficient of x's will be giving me negative 2a on the left hand side, and that will be equivalent to negative 10 on the right hand side. So solving for a will be equal to dividing through by negative 2, and that will give me 5. A is 5. And then comparing the true constants, we have a squared plus b should be equal to 29. So we know the value of a as actually 5. So we substitute. So we have 5 squared plus b equal to 29. And therefore, b will be equal to 29 minus actually 25. And therefore, b will be equal to the number 4. But we were asked to find a plus b. A plus b. So finding a plus b, we are going to get the answer as a value 5 plus 4, and that is 9. And that is 9. That is 9. Thank you so much, my people, for joining this call. I'm so privileged to having you gone through a lengthy lesson such as rational function. We've taken as many work examples as well as some WASI work examples. Thank you so much. Please subscribe to my channel if you haven't, and then kindly share the link for my videos to other friends so that they can also equally learn. Thank you so much and have a nice day. God bless you.